In this video, we'll balance the equation for K3PO4 plus Al2SO4 3. This is potassium phosphate plus aluminum sulfate here. These are aqueous. In fact, everything is aqueous except for the AlPO4. You know your solubility rules. This is going to be a solid, so this will be our precipitate right here. We could write S after it if we wanted to. So to balance the equation, what we can do is count up all the atoms, and we're going to use a trick to make this a lot easier. We have 3 potassium atoms. Then this phosphate ion here, it's a polyatomic ion. We have it on each side, so we just count it as one thing. We have 1 phosphate ion here, 2 aluminum atoms, and then the sulfate. Same thing, I have a sulfate ion here, sulfate ion here. So since I have them on both sides, I just count it as one thing. I have 1 sulfate times 3. So I have 3 sulfate ions. Product side, 2 potassiums. Phosphate side, I have just the 1. I have 1 aluminum, and then I have 1 sulfate ion. So you see, this is much easier to work with than counting up all these individual atoms, as long as we have the ion on both sides. So to balance this, I'm going to start with the sulfate, because if I start with the sulfate, I can see that'll change my potassium to a large number. So this way I won't have to keep going back and forth. So I'll put a 3 here. I have 2 times 3. That'll give me 6 potassium atoms, but my 1 sulfate times 3, that'll give me 3. So I've balanced the sulfates here, these SO4 ions. I could, at this point, multiply 2 times the potassium phosphate, 3 times 2. That'll give me 6. Now the potassium atoms are balanced, but I have the 1 phosphate times 2. So I have 2 of those. Could just put a 2 here. Now I have 1 aluminum times 2. That gives me 2 aluminums. That actually balances the aluminums. My 1 phosphate here times the 2. That'd give me 2 phosphate ions, and we're done. This equation is balanced. Very useful to count these polyatomic ions as one thing if they're on both sides. And again, these 2 compounds will be aqueous. They're soluble in water, so they're dissolved in water. When they react, they produce this solid here, and that's going to be the precipitate that'll fall to the bottom of the test tube. That's why we say that this reaction happens. This is Dr. B with the balanced equation for K3PO4 plus Al2SO4 3. Thanks for watching.